Hello everyone. Now I am in live session. Have any queries? You can ask me. Today we are in live session for the course. All of you are very well familiar about the course now. That is actually welding application. The course title is welding application technology. So in this course, you have already got the idea about what is the course content. So in details, some content of this course already you have got. Already have completed also different lecture modules of this course. So I feel these courses are very much interesting to all of you, because in this course you got the flavor of different what it's called welding process, which are especially used in traditional engineer with traditional industrial purpose, that you can say. Apart from this thing, in this course you got the idea about what it's called what is the cause of welding in a structure. That means once we do the welding in a specimen or a structure, then due to this welding, we can say intentionally we used to create some defect in that structure. The major defect of that welding specimen, you can say, is the welding induced residual stress and distortion. Distortion means what happens when we do the welding due to thermal expansion, non-even thermal expansion and contraction. What happens there can be occur different shape changes of the structure. That means the structural shape changes. That shape changes can be different types. You have already observed that things. Around 5 different categories of welding deformations are there. There you observe that there can be longitudinal shrinkage, transverse shrinkage, angular deformation, then rotational types of what it's called distortion. You also observe that there can be buckling types of distortion, then bending types of distortion. So many different types of categories of distortion related things can arise due to the effect of welding that you observe. Apart from these things, another one of the most critical part of welding process is welding induced residual stress. This welding induced, that means once you do the welding in a structure due to uneven expansion and contraction in the welding specimen, there occurs some what it's called weld induced residual stress. This weld induced residual stress is a, you can say, phenomena. You can say is a dangerous phenomena in welding process, because this welding induced residual stress will have a negative effect in case of life of what it's called welded specimen, that you can say, because generally fatigue life of a welded specimen depends on well-induced residual stress significantly, that you can say, because this well-induced residual stress, it's a what it's called locked in stress after what it's called, you can say, after welding. Once you remove all externally applied load, then also this stress locked inside the structure. Due to these things, what happens, the load bearing capacity of a structure is reduced drastically. So it has, that's why what happens in case of welded zone, most of the cases it is observed that most of the material, it is observed that in near the weld zone, the well-induced residual stress is tensile in nature. So tensile in nature residual stress generally have a negative effect in fatigue life of a structure, because once a structure is subjected to some tensile types of residual stress, then its fatigue life reduces. That you should keep it in mind. That means effect of residual stress, you can say like this. So that's why what happens in this present course, we have discussed in details what is residual stress due to welding, and what is the cause of this well-induced residual stress, what are the type of different, that means what are the different type of well-induced residual stress. In details we have discussed in this course. And apart from these things, in this course, I have discussed in details about what it's called, how we can measure the residual stress. So this residual stress experimentally we can measure by using different method. So this method in brief we can categorize, or you can say we can group into three different categories. The first categories is generally destructive types of techniques. So in destructive type of techniques, you already observed that this technique generally result in a large and irreparable structural change to the specimen, meaning that either this specimen generally cannot be returned to the service, or you can say it become a spare part, that, or you can say a spare part must be used. So this destructive technique means we destroy the specimen to measure the residual stress, that you can say. So these types of techniques, already you observe that there are different types of categories of destructive techniques are there. Some of the techniques named like contour method, is slitting method, block removal method, surge boring techniques. These are the different types of destructive techniques which I have discussed in detail in this course. This experimental methodology which I have discussed in detail in this course. Apart from these things, you observe that there are another categories that is called non-destructive or NDT testing. So in NDT testing, generally it's measure the effect of relationship between the residual stress and their action of crystallographic property of the measured material. That means due to residual stress, whatever the crystallographic changes occur, that means atomic lattice spacing and other things changes. So based on that lattice structure or atomic structure, or you can say crystallographic structural changes, based on those things, generally we can make a relationship between these changes versus the amount of residual stresses. For that also, we observe that there are different types of what it's called techniques are there. Some of the techniques, like you observe that Newton diffraction techniques, then what happens, synchrotron diffraction techniques, X-ray diffraction technique, then ultrasonic technique, magnetic techniques. So these are all different very important NDT, or you can say non-destructive techniques are there, which have a wide application for measuring these residual stresses. So you see, so in this non-destructive technique, generally here what we used to do here, generally some of this work by measuring the diffraction of high frequency electromagnetic radiation through the atomic lattice spacing relative to a stress-free sample. Generally, what we used to do, we compare the lattice spacing between a residual stress-free and with residual stress specimen. Based on these things, we can measure the what it's called residual stress of a welded specimen. For that, here we use a high-frequency electromagnetic radiation. This you should keep it in mind. There are some other techniques also there that is lying in between the destructive and non-destructive technique, that is called semi-destructive technique. This semi-destructive techniques also is a very, you can say, interesting techniques. In this technique, generally what happens here, we used to say, here we use some techniques where we are not destroying the specimen fully. Here, this technique is more or less similar to destructive technique, but what happens here, generally this technique generally remove only a small amount of material, and here generally the overall structural integrity remain intact, that you can say. That means here the structure we can use further. So this destructive and non-destructive technique, both the techniques is used by a principle. That principle name is strain release principle. I have already told you the cause of, in last live session, I have already told you that cause of residual stress is mainly what is called elastic strain. That I have already told you. That means this elastic strain, once you generally cut that location, or that elastic strain is recoverable, that you can say. That means we can release the stress from a particular location by removing the whatever support of the things. What I am telling you, understand? That means like what happens because elastic strain is a recoverable strain. That means once you release the load causing this elastic strain, then what happens, the material can return back to its original position or original state, that you can say. That's why what happens, this destructive and semi-destructive technique use that principle, where we generally card the location where we want to measure the what is called stress. Once we card that location, then this stress part will release, and what happens, whatever the strain is developed due to releasing of the stress or due to the return back of its original position, whatever the strain is developed, that strain generally we measure with the help of some strain gauge. That strain gauge can be what is electronic strain gauge, or that can be a mechanical gauge, or you can say some what is called a transducer also we can use to measure those types of releasing effect. So by using these things, generally what you can do, we can measure the well-induced residual stress. Like semi-destructive techniques is quite popular techniques nowadays, like deep hole drilling technique, center hole drilling technique, ring core method. So these are all different types of semi-destructive well-induced residual stress measurement method. So these that means destructive as well as non-destructive techniques, it's follow a principle that is generally called strain release principle. This you should keep it in mind. Okay. So these are the questions asked by a student in telephone, in my actually office telephone. That's why I am discussing a little bit here. So one thing you should keep it in mind, these all residual stress measurement techniques is generally is a costly techniques, one you can say. So among these generally NDT technique are quite costly because like for X-ray, XRD techniques, or you can say X-ray diffraction technique, neutron diffraction technique, this types of machine cost is quite very high. Like it can cost, it can have a cost within a range of some crore rupees, that you can say. Okay. So and some problem of this XRD techniques, you can say the XRD technique generally can measure the residual stress within the surface level. Within some micron of surface level, it can measure the residual stress. Whereas neutron diffraction have a very good penetration capabilities. That's why it can measure the inherent thickness direction of the residual stress part also. But neutron diffraction machine cost is quite very high. Its cost is more than crore rupees, that you can say. Okay. But this destructive and non-destructive, semi-destructive techniques, these two techniques is quite less cost techniques, you can say. There generally we use some strain gauge or a strain gauge, you can say, which is the electronic component. This strain gauge generally it's convert that expansion and contraction part in terms of voltage difference. That voltage difference generally we calibrate with the help of some data acquisition system. It's connected with computer, data acquisition system to computer. From there generally we can calibrate, or you can find out how much strain release is taken place. Based on this thing, generally we can measure the residual stresses. That part actually I have discussed in this course in detail. But as you discuss this thing, that's why I'm a little bit discussing here also. Now, one of the students asked me, sir, can you please explain what it's called? 1 minute. One of the students asked me what is that means due to welding, how the residual stress generally generated though I have discussed this thing in one of my lecture in details, once you follow this lecture, definitely you will get detailed idea. But if you want, again, I can discuss here also that things. Okay, so that things now I am going to discuss again. So for that, actually, I need to draw a diagram. That diagram I am going to draw now. So after that, another student also asked one question, sir, can you please briefly elaborate in ANSYS how we can predict this well-induced residual stress and distortion? So that's the two things actually today I will discuss. So first of all, I'll discuss about how we can analyze numerically to predict the residual stress. So that things now I am going to discuss. So for that, actually, I need to share the screen. So I'm going to share this screen now. After that, I'll briefly discuss about that process. In between, if you have any queries, you can ask me. So now I'm going to discuss about what is called by using ANSYS software, how we can what is called predict the residual stress and distortion, that you can say. So first of all, you need to know what is ANSYS. So ANSYS, its full form, you can say, little bit I am explaining that it you can it will be very clear to you. So ANSYS, you one. Yes. So you see this ANSYS. First of all, I'll discuss by using ANSYS software how we can predict the thermal history, then residual stress and distortion. After that, if time permit, I will go to discuss about what it's called in welding, how the residual stress is induced. That related thing also briefly I'll discuss. So ANSYS, its full form is AN means analysis, and SYS means system, that you can say. So ANSYS is an analysis system. This ANSYS software is generally based on based on a numerical method. Based on a numerical method. That method name is finite element method. Finite element method, or you can say FEM method. So you know there are different types of what is called numerical method are there. First of all, you need to know what is the difference between numerical method and analytical method. The numerical method means it gives you approximate solution, whereas generally analytical method means it gives you exact solution. Okay, so how the difference is look like that, I'll show in subsequent slide. Then it will be very clear to you. So ANSYS software is based on finite element method, which generally follow a approximate method, which follows a approximate method, that is finite element method. So in ANSYS software, generally there are different types of modules are there. So like ANSYS multiphysics, ANSYS then ANSYS dynamic analysis for purpose, ANSYS LS Dyna, ANSYS mechanical part, ANSYS electrical part. So there are different types of modules are there. By this, generally we can do the what is called different types of analysis that you can say. So in ANSYS, generally whatever the method it's used, that name is called finite element method. Here you can see I have written here FEM, or it is also you can say is called FEA analysis, finite element analysis. A represent analysis, FEM represent finite element method. So for doing what is called finite element analysis using ANSYS software, first and foremost things we need to do, we need to make the model of that structure. So that means here I have written, that means first we need to do the modeling part. So 1 minute. So this so first and foremost things we need to do, that is modeling part. Modeling part, let us consider here. You see, we need to do the analysis of a what it's called beam, whose cross section is, let us consider, a square in nature. So for that reason, here I have shown. Let us consider this beam have a length. Here you can see L, and it has a cross section which is a square in nature. I have drawn this thing. So in ANSYS module, how to do this thing, that I will show. Then after that, in finite element method means here we need to divide this structure, let it be beam or plate, whatever it is, or it can be a complicated structure, combination of beam, element, plate, then column and all the things. A complicated structure can be there. So one individual structure, just here I am showing for your understanding purpose. Who is very new actually in this field, for them actually I am starting this thing from the scratch, that you can say. So you see, for this first of all we need to do the model. After that, this model we need to divide into a small part. You can see I have divided this beam into a number of division, a small division. So one of the division I have taken it out. If this division is known as, this division is one division of that one division of this what is called a model part or a structural part is known as element, that you can say. And the corner point of this, you can say, of that element is called node. What I am telling, understand? Node. So this node sometimes can be in between the element also. What I am telling, in between the line of this two corner point also. This what is called a node can be there. This you should. For that there are different types of some super elements, sub elements. These types of elements are there. So that we are not going to discuss here. Just I am giving you some brief idea about what is called ANSYS software and what are the basic numerical method it's used. Now you see here, first of all, before going to do actual analysis, first and foremost things we need to do in ANSYS software is we need to first what is called do the mesh sensitivity analysis. What is mesh sensitivity analysis? That part here I have discussed in details. Mesh sensitivity analysis, let us consider we want to find out the what is called area of a circle. Let us consider this is the area of a circle. So its radius is r. So this area of a circle we can find out by what is called by analytical method. That formula we know, that A is equal to pi r square. This pi have a standard value, that is actually 22/7, that you know very well. And what happens, this r is the radius of this circle. By this you can easily find out the what is called area of this circle. But in finite element method, generally what we used to do, we need to divide this area into particular number of known geometrical shape. like this is one a triangle, this is another triangle, this is another triangle, this is another triangle. After that, this triangular, what it's called area, we can easily find out that area, triangular area, you can say area of triangle equal to half into base into height. Correct? This we know very well. So by this we can find out the area of a triangle. So once you sum it up of this all area, how many areas are there in this circle, then what happens, we can get a approximate what is called area of that circle. Once we add the triangular area of each triangular area, sum it up, then we can get a approximate area of this circle. Now you see, you can observe that. So this one triangular division, you can say, is called a element. So if we increase the number of this triangular element, that what we can observe, if we increase the number of division, you can say, that means number of triangular element, then we can get more and more, you can say, accurate result, which is close to the actual analytical value, which is obtained by pi r square value, that you can say. So that things here I have represented, you can see. So this lower, so you can divide this circular area internal way or external way. Once you divided this circular area internally, that is generally called lower bound. That method is called lower bound convergence method. And the area, once we divide external way, then that method you can consider as upper bound convergence method. So you see here I have plotted this line and this upper line, you can observe that this. So this horizontal axis represents number of element. Number of element means if we divide this circular area into more and more number of triangular element, then what happens? The result will be very close to pi r square value. Correct? This you can observe from this diagram itself. So if we increase the number of division more and more, it will become close to the actual value. You see, it's close to the actual value. But what happens? It will never give you the 100% accurate result. It can have a value which is 99.99999, that value also, if we increase the number of triangular element more and more. But it will never give you 100% accurate result. So at a particular level of, you can see, at a particular range of number of division, you will observe that with further decrease of element size, generally what it's called, your that means your accuracy is not coming very high level, that you can say. But one thing you should keep it in mind in finite element method, once we increase the number of division or number of element more and more in a structure, then what happens is computational time increase drastically. That you should keep it in mind. That means computational time also is more and more. That's why what happens. So after certain level of number of division, if you increase the further division, you will observe that your change of that accuracy is marginal. So you can consider that where the change of accuracy is becoming marginal, before that, whatever the level of number of element were there, that element you can consider your what is called converging number of element. That you can consider. What I am telling, understand? This you should keep it in mind, because you can make more and more number of division, but once you increase more and more number of division, then what happens? Your accuracy will increase, but that accuracy will generally, for a small accuracy, you can spend a lot of time to get the solution. This you should keep it in mind. That's why first and foremost things you need to do for doing what is finite element analysis by using what is called FEM method. First and foremost things you need to do, that is called your mesh sensitivity analysis or mesh convergence analysis. This you should keep it in mind. This one you should keep it in mind. Now, in ANSYS, how we can use ANSYS? A newcomer, how generally he start ANSYS software. That things here I am showing. So once we install the ANSYS software in a computer, then you can observe there will come a icon which is shown here, like you can observe that is ANSYS product configuration. So once we double click in this ANSYS product configuration, then a window will appear which is look like this. You can see. So in this window, there are different types of what it's called file management, customization, preferences, then launch. These types of option is there. So in launch option, you can have different types of license module. So generally, here the license module, here will be the cost of this software. This you should keep it in mind. That's why what happens, it is observed that for doing thermomechanical analysis, but depending upon your analysis time, it is better to procure that types of module. This you should keep it in mind. Then what happens, you can save money for what is called for your this software procurement purpose itself. Like for doing, let us consider I want to do thermomechanical analysis for prediction of residual stress and distortion. Then welding mechanical, ANSYS mechanical is a good module for that. Then ANSYS multiphysics also. Multiphysics means in this module you can do different types of physics of simulation, like thermal, structural, then thermomech, combine of that two. Then even some fluid structural interaction. So these types of different part you can do with the help of this ANSYS multiphysics. That's why what happens here, I choose ANSYS multiphysics, what is called license module. What I'm telling, understand? After that, once you run, here you see a run button is there. Once you click on run, then what happens, your main window will come. So before going to open main window, here you can do some another operation that is generally called file management. File management means where we want to store the data, where we want to do the analysis. For that, generally, we need to define our working directory. For defining working directory, generally, you can use this DOS format. What I'm telling, understands? Like, see, I am just let's storing this thing in document and setting. A folder name is let's Pankaj. So in this Pankaj folder, that means our analysis, all the things analysis data will be stored there. Now let job title name is let's structural, or it can be thermomechanical analysis. You can write this thing because that option is there. So after that, once we run the things, here you see. So here I have written like this. Let's welding simulation. Here I have written. So here we user menu, see user menu. I have created what it's called folder in desktop. So by using this DOS format, I have generally showing you the how to make the working directory. So here I have opened a working directory in what is called in desktop itself, and that working directory's folder name is welding simulation. What I'm telling you, 2020. And its analysis job name is, let us consider welding analysis. That you can observe here. I have written this thing. After that, if you click run, then your main window will come. Here you can see this is the main window. This main window appear. Now in this main window, we need to first, I have already told you, we need to first model the things. After that, we need to discretize the things. After that, we need to, what it's called, discretize. It means we need to divide that model. Then we need to do the analysis, and finally we need to check the what it's called results. So how we can do these things, that step generally is provided here in details. So this first 5 steps generally is very important steps. These first five steps are the most important steps. This you should keep it in mind. The first step name is, you see, preferences. Then another one is called preprocessor. Then another one is called solution. then general post-processor, and time history post-processor. These are the different 5 important steps are there. So each step have some sub-steps. So what are those? Once I solve this thing, then it will be very clear to you. I'll just show you how to do these things. Okay. So first of all, in preferences, in this preferences, what we can do, that I am showing. So once you click preferences, that I am going to discuss now. So once you click preferences, you can observe a window will come, which is look like this. So in this window, you can observe that so many different types of analysis you can do, like a structural, thermal, then fluid, then float run. So CFD, and there can be magnetic, there can be magnetic nodal, magnetic edge, high frequency, elastic, so electric. So different types of process you can select depending upon your type of analysis. So generally for doing welding analysis, we need to select structural and thermal, you can say thermal parts. So if we select these things, select means once we click this thing, a dot will appear here and a dot will appear here. So I am just showing in next slide. So I select that dot means a tick is appeared here. You can see a structural I selected, and this thermal also I selected. This tick is come. After that, we need to do OK, because thermomechanical analysis is a thermal as well as structural analysis. So thermal analysis means first we need to do temperature distribution analysis. Then this temperature distribution analysis we need to take as a load in a structural analysis, where due to this thermal loading temperature data, how the what is called structural changes occur, that related thing generally we need to do. That's why these two icon we need to select. So after selecting this thing, we need to click on OK. So then what happens? So structural, thermal related, whatever the things are required, that things is selected now. Okay. Now after that, we need to go next step, that is called preprocessor. So preferences done. Now preprocessor. In preprocessor, you can do lot of operation. So here generally we need to select what types of element type, what is the unit we are going to use, whether it is SI unit, CGS unit, or FPS unit, or MKS unit. That unit actually we need to define here. Then here we can put the material property. That means here we need to define whatever the structure we are using. That structure is a steel material or composite material or plastic material or ceramic material. That related thing, general information we need to put depending upon its material property. That generally we need to put with the help of this. After that, generally that structural modeling part we need to do. Modeling part means how the structure is look like, whether it is a curved beam, whether it is a straight beam, it is a circular cross section, taper cross section, uniformly varying cross section, how it's look like. So everything we generally need to model here. After that, in this preprocessor itself, we can discretize that model part. Discretize this model part means we can divide this model, that means beam, into number of small division. So one division is called an element, and its corner point you can say is normally called as a node. I have already told you this node can be in between the what is called corner point also. But that actually separate types of elements are there. This you should keep it in mind. Okay, so these are the operations which you can do with the help of this preprocessor menu. How it is, that I am going to show in subsequent slides that you can see. So first of all, here most important things you need to do, you need to define the element type. What is element type? Element type generally for thermomechanical analysis purpose, for thermal analysis, generally thermal formulation, that in general way, very simple way you can say. The thermal formulation part generally, thermal formulation part and its detailed programming generally made in a particular folder. That folder generally give a name. that folder name is called thermal element. So that thermal element, it can have a number. What I'm telling, understand? So for different types of thermal analysis, different types of formulation, researchers are made and they put in different types of folder. For that, for thermal analysis purpose itself, there can be different number of what is called thermal elements. What I'm telling, understand? So for our case, we are going to do three-dimensional thermomechanical welding analysis for prediction of residual stress, thermal history, as well as distortion. So for predicting these things, we already go through different types of elements where generally this formulation are made. So we go through that initial study of that element, and we observe that which folder contain this welding related analysis formulation. So that thing generally we need to first study and decide that folder type, and that folder type generally we need to select based by using this step. What I'm telling, understand? So if you will select a wrong folder, then what happens? You will not be able to do the analysis. Like for let's you are doing a thermal analysis, but if you choose a structural element where a structural formulation generally are provided, then what happens here? You will not be able to do any analysis which is related to thermal analysis. This you think, this you should keep it in mind. Okay. So that part generally here we need to do. So for that, actually here you see the option are in preprocessor. Here there is element type option is there. So after that you need to do add, edit, delete. So in add, edit, delete, if you click add, edit, delete, then what happens? A window will appear. So a window will appear which looks like this. First this window will appear. So after that, generally, if you in this window you see there are this thermal mass of thermal mass means element type is thermal mass. Let us consider here we are doing three-dimensional analysis. So this element type is solid element. So solid element, if you just click in left side, you can observe in right side so many different types of this thermal mass solid element are there that you can observe. So it is observed that for doing welding analysis, solid 70 is very good enough. Means solid 70 give you a very good accurate result, where generally formulation related to Fourier heat conduction equation, then what happens moving heat source, element birth and death, then what happens for thermal related different types of boundary condition like convection, conduction, radiation. So these types of then combined boundary condition can be fluid structure interaction by boundary condition. So these types of boundary condition generally you can put. And these types of options generally available in this 8-noded solid 70 element. What I'm telling, understand? That's why I have selected this solid 70 element. So once I select this solid 70 element, after that once we click on OK, then what happens? This element will be selected. That means now you can choose a right folder where generally thermal analysis related all programming, all formulation is given there. What I'm telling, understand? Now only you can do thermal analysis part, because for welding generally first of all you need to do the thermal analysis. After that this thermal temperature data you need to use in a structural analysis to find out the residual stress and distortion. This you should keep it in mind. So that things I have selected. After that once we click on OK, then what happens? That means solid 70 element will be selected. Always you should keep it in mind for doing welding analysis using what it's called using what it's called ANSYS software. Solid 70 is good enough to do three-dimensional tangent thermal analysis. This you should keep it in mind. Okay. So you see, so this solid 70 element which select. After that, generally we need to do the modeling part. You see, this is the modeling part. this model part, actually how to make this model. You see, this is a plate structure. So this is one plate, here the weld zone, and here the what is called another plate. So in between, generally this welding will be done. Okay, so how to do the modeling part, that part also I'll discuss if time permit. Okay, the modeling part is very simple. Generally for making model, what are the different things required to do, I'll show you. So after making model, here generally we need to put the material property. So material property here, first of all, we need to define the temperature unit. So by default, generally temperature unit is in SI unit, that is in Kelvin. But here you can choose according to your by drop down this what it's called arrow. We can choose Celsius or Fahrenheit or Kelvin, whatever the things required. So here we choose Celsius. Okay. So after that, so whatever the temperature data or temperature history this analysis will provide, that will give you what is called Celsius data. Now we need to put the material property. So how we can put the material property? For putting the material property of that material, let us consider this analysis we are going to do in a steel material. So for that, we need to define the steel material. So before discretization, that means before the meshing, we need to put the material property. So how you can decide what types of material property is required, what types of material property generally are required for this analysis, how you will decide. For deciding that material property, first and foremost thing you need to know what is the governing equation required to do the thermal analysis. So all of you are very well familiar generally for doing thermal analysis. What we need to use? We need to use the governing equation, that is actually Fourier heat conduction equation. So Fourier heat conduction equation in one dimensional case I am just showing, that is actually del 2T by del x square is equal to, that means K into del 2T by del x square is equal to your rho C delta T by delta small t. So this governing equation is required to know. Here generally the output is, this is one dimensional, this is 1D governing equation. For three dimensional case generally K del 2T by del x square plus K del 2T by del y square plus K del 2T by del z square equal to this thing. That you know very well. So one dimensional case actually I am just showing. So here the output is, what is the output here? So in this equation general, this is called the governing equation of thermal analysis. So here the output is your temperature T. So for getting the temperature in this equation, what are the input required? So for getting the temperature, here the input required are all other things. What I am telling, understand? That means here input required is K is the thermal conductivity. K is the thermal conductivity, you know. X is the coordinate. Then rho is the density. C is the specific heat. And T is the time. So all this data, once you know, then only you can find out what is T value. Correct? So how we can put this input parameters or input value? So for that, you need to know the steps. Like this coordinate X, Y, Z, this you can put by drawing the geometry. Once you drawing the geometry, there you generally define the coordinates. But this K, rho, C, how this K is thermal conductivity, rho is density, C is the specific heat, and T is the time. How you can input these things in this equation so that you can get the output T value. So before going to do any analysis, first and foremost things you need to know what are the input required to put in this analysis. Because if you will not put one of the parameters, one of the input parameters in your model, you will not get the temperature data. That's why first and foremost thing required to know what governing equation generally is used to do the what is called thermal analysis. For doing any types of analysis, by using any types of commercially available software packages, first and foremost things you need to do, generally, what is the governing equation required to do this analysis? If you know this governing equation, then only you can define what is the input parameter and output parameters. Input and output parameters are there. What I am telling, understand? This you should keep it in mind. So for that, that's why what I am telling here also you can see here the output is T, but once you provide this 5 input parameter, then only you can solve this governing equation and you can get the solution. So these 5, any one of the input parameter, if you will not define, then what happens? Your things will not come. That means you will not get the actual temperature data. So that's why here I have shown generally, here I have shown you that, okay, here I have put the density, then specificate, then thermal conductivity. So these are the things I have put here. And by using this, what is called welding velocity, we will put the time. And by using the geometry, we will put the, what is called model, we will put the geometrical data. These are the things you should keep it in mind. Now, for putting these input parameters here in material property menu, here you see left side in material property menu, there is a menu that is called material model. So in this material model, so once you double click, then what happens? Here you will get these types of all different types of material properties input table. What I'm telling, understand? So in this input table, you can put a constant material property which is not temperature dependent, or you can put temperature dependent material property also. Like here I have generally put a temperature dependent material property that you can observe. What I'm telling, understand? So by this generally you can put, there is option add temperature. If you just do this button, once you click, then what happens? You can get a new number of columns. What I'm telling you, the new number of column you can add. There you can put the, what is called, there you can put these types of temperature data. This you should keep it in mind. Okay. These are the things you can see. These are the data I have put here. So by this generally you need to put all the data. After that generally what you need to do, you need to, what it's called, put the, that means after putting these things, you need to, what is called, discretize the model. So before putting the, what is called, input material property, if you just discretize or mesh the model, then what happens? Your element will not consider that data. That's why what happens, before dividing the structure, you need to put the material data. After that only you need to go for doing the meshing operation or division operation. Then only your model will consider that input. That means your element will consider that input material property. This you should keep it in mind. Here I have shown actually how to do the modeling part. Little bit that I will discuss. After that, actually, this related information, actually more detail I have discussed in my course, in this course itself. So you can get more detailed idea once you go gradually to do further and further module. Then there you will get detailed information about this simulation part. Apart from these things, if you will have any queries about this course for this analysis related things, you can directly contact with me also. So here, first of all, I am showing you how to make a model. So for making model, generally very simple steps here I have shown. You can start the modeling part from the corner point of that structure. After that, first you need to define that point, or you can say key point. That by this key point you can draw a line. That line can be a straight line, curved line, that types of things you can draw. By line you can draw a area. By area you can make a volume. So how from the scratch, from a coordinate point, you can develop a final geometry, that related information here I'll give After that, generally what happens? If this analysis related things today, I will not get much time. So analysis related things already I have provided in my what is called course. There you will get the detailed information. As you were telling related to ANSYS software related overview, that's why I am giving you some overview of this ANSYS software. Okay. So here generally you see, first of all, I have I want to make a what is called rectangular plate, or you can say rectangular plate which have a thickness. We have a dimension is 100 millimeter by 100 millimeter by 100 millimeter. So for that, generally we need to define 4 key point. This is key point number 1. This is 2. This is 3, and this is 4. This you need to define. So for that, generally you can see in modeling option, left side you can see there is a create option. That create option, there is another point, that is key point. In this key point, you need to select in active coordinate. If you select active coordinate, then what happens? These types of window will appear. So in this window, what you need to do? You need to here define the first key point 1. This key point coordinate you need to define, that is your x and y, because here you see this is the xyz coordinate is there. So x and y coordinate you need to define here. So this at that time, first once the key point is 1, then here you need to put 1. Always you should keep it in mind. Then second key point, here you need to put 2. Third key point, here you need to put 3. And fourth key point, you need to put what is called 4. This you should keep it in mind. If you will not change this key point number, then what happens? The same location, all the key point will be generated. What I am telling, and that's why it will be overlapped. That means one key point will shape from one place to another place. What I am telling, understand? So for different key point, different key point number you need to put. That's why 4 different key point, 4 corner point, 4 key point number I have put here. You can see. So after that, second step, you can say create. First key point is over, then line is come. So in this line, you need to draw the line. So I am interested to draw the straight line. So a straight line I have drawn. This is 1 to 2, one straight line, 2 to 3, another straight line, 3 to 4, another straight line, 4 to 1, another straight line. So by this, I draw the 4 line. Now by this 4 line, I can directly generate the volume. But why I am showing all these steps? So that you can generate your own structure as per your requirement with any types of geometry, so that you can develop. That's why I am showing this thing. So here you can create curved line in between 1 to 2, 2 to 3, 3 to 4, 4 to 1. What I am telling, understand? These are the things you should keep it in mind. Okay. Now, after joining this line, by this line, actually, I need to create an area. So you see, next step is area option. You see, in this area, create area, arbitrary area I am just creating. That area I am creating by line. You see, this line I have selected. So this 4 line I have selected. Okay. By this 4 line, generally, once you selected and click on OK, what happens? It will create an area I am showing in subsequent slide. So this is the area created. So now this area, let us consider we want to what is called make a volume. How to make a volume? We want to put a thickness. So this you can create directly by clicking on volume. In this left side button is there, left side menu is there. So by using left side, you can directly create this thing. But I am showing step by step so that you can generate your own geometry as per your requirement. This you should keep it in mind. Then after that, what I want to do, I want to extrude the area. So this area I am creating. So in modeling, there is the option operate. So there in operate option, there is the option extrude. In this extrude, there is extrude means extrusion. That means along which direction you want to extend the area. That I want to do. Okay. So that's why I am selecting this area after clicking on extrude along normal, and I select this area. Once we select this area and click on OK, a new window will come. And that window will ask, what is the length of extrusion? You see, here it is given. What is the length of extrusion? So this length of extrusion, generally, here let us consider I am putting 5 millimeter length of extrusion. 5 millimeter means 0.005. This you should keep 0.005. That I put here. Okay. So after that, you see it is converted to a volume. Okay. So this way you can generate the model. Okay. Now this model you need to now make meshing operation. So this way actually I am showing, let us consider this is on side weld plate, this is another side weld plate, and this is middle weld zone. Okay. This way let us consider I want to create what it's called. I want to create the modeling part. Now, how to mesh these things? For meshing operation, you see modeling. After that, next window is this operation is meshing. Meshing means we need to discretize the volume. For discretizing the volume, generally here you see in left side meshing operation is there. In meshing operation, generally is mesh tool is there. By mesh tool, you can divide the line as per your requirement. You see, as per a requirement, you can divide the line. And what happens? After that, generally you can do the division. Like here, we want to make fine mesh near the weld zone. Away from the weld zone, we want to make coarse mesh. That's why I divide this. You can see, I divide this line into finer near the weld zone and coarse away from the weld zone. That you can observe also here also. What I am telling, understand? Here also you can observe. After that, once we just mesh these things, then your shape will come like this. Here you see, in weld zone it is finer mesh. Away from the weld zone, generally it is gradually generally coarsening in nature. This you should keep it in mind. So this way generally meshing is required to do. Okay. So as the time is off, so up to meshing part actually I am discussing. So rest of the things, if you want to learn from me, you can directly contact with me. Otherwise, what happens? Rest of the things I have provided in this what is called course itself. And another of my course also is there. That in that course I have discussed in details about all these things. That course name is Fundamental of Thermomechanical and Fatigue Analysis of Welded Structure. That is a very interesting course. There you can get what is called detailed idea about this analysis part. So where I have discussed in details about all this thermomechanical analysis related things. Okay. So thank you. If you have any further queries, you can ask me later on also. I am always available for you. This one you should keep it in mind. Okay. I think no further queries are there. So, hello. 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 Buddy, time is up. Okay. This one. So I think no further queries are there. Okay. Okay. Thank you. Bye. I am leaving, right? Thank you. Let's go through this course thoroughly. You will get a lot of information. This one, just I want to say. Thank you. I'm leaving now.